Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph our cosine function when we're given a phase shift. And basically the phase shift is just going to be shifting the graph left or right. So before we get into graphing though, it's also important to understand what are the different characteristics or the transformations that can affect the graph. Well, to see what the graph is here, again, what we have is the parent graph, or what I have at least is the initial period of the parent graph. I also have just the kind of general function y equals cosine of x. But now what we're going to be graphing is when we have equations that are in the form y equals a times cosine of bx minus c. And when we have values for a, b, and c, that's going to tell us that, one, we're going to have an amplitude, right? Or we always have an amplitude for cosine, but that's going to help us determine our amplitude. B is going to help us determine our period, and then the bx minus c is actually going to determine our phase shift. So there's a couple different ways we can go ahead and determine the phase shift, but basically the best thing we'll be able to do is we'll get into it. But before we want to do that, we want to get down the important information that we already know. Again, the first thing before we even graph any trigonometric function is we always want to be able to identify our key components. And the main important thing is to identify the amplitude, which is just the absolute value of a. So absolute value of a in this case is 4. So that's just going to be absolute value of 4, which is just going to be 4. Remember, amplitude represents the half distance from the maximum to the minimum of your graph. The next thing we need to do is determine the period. And I hope I gave myself enough space. So the period, if you remember, is going to be 2 pi divided by b, where b is going to be the value that's multiplied by your variable inside of the function, your variable x. So therefore, I'm just going to have 2 pi here divided by 2. Well, that's going to divide out, and we're just left with pi. That means the distance that it's going to take the graph from start to end is going to be pi, whereas the initial period, you can see the distance it takes is 2 pi. The also important thing is about this initial scale, or the scales, you can see that it's broken up into 4 sections, 1, 2, 3, 4, where the distance between each of those sections is the same. That's our scaling. So to determine the x scale of your graph, basically what we're going to do is take our period and divide it by 4. So that's going to be pi over 4. Now, the reason why I haven't sketched anything on the graph yet is because once I notice that I have a phase shift, I'm going to want to determine where our start is. And we don't really necessarily have to do the end. I always like to just determine where exactly is the start, because it's not always at the y-intercept. Yes, the initial period starts at the y-intercept, right? But now when we have a phase shift, we're shifting that initial period left or right. So to determine the start, basically what you're going to do is you're going to take bx minus c and set it equal to 0. So I'll do that work over here. So what I'll do is in here, our bx minus c is 2x plus pi. So I'm going to take 2x plus pi and set it equal to 0. Now what we're going to do is we're going to solve for x. So I'll subtract pi. And therefore I have 2x equals negative pi divided by 2 divided by 2. X equals negative pi halves. OK, so now what that's going to tell me is I'm not going to be starting at 0 like we previously always did. I'm going to start at negative pi halves. Now, that's not to say, though, that we should not include where exactly the y-intercept is. So I'm going to do my typical graph, just like I would do before, right? But now I am going to say, well, OK, now what I'm going to say is, all right, here's negative pi halves. All right? And we can see that now my x scale is going to be pi over 4. So that means I need to add pi over 4. So if you want to look at this in force, you can really look at this as negative 2 pi over 4. Right? It's the same thing. And the reason why I like this, though, is because when you're adding force, the 4 in the denominator remains the same. You're just adding the numerators. So in my next point, that's going to be a negative pi over 4. The next point is going to be 0. OK? So now what I'm going to do is just use a different color to say, hey, this is going to represent my y-axis. All right? And we're not starting at the y-axis like we did before. Then the next point is going to be pi halves. I'm sorry, pi over 4, right? Because we're adding one force. And then the last one is going to be pi halves. And you can see here that now I have 1, 2, 3, 4. I've now completed a period, right? But I want to complete 2 periods, so I'm just going to keep on going. So that would be 2 pi over 4. So if I keep on going, this would be 3 pi over 4. This would be 4 pi over 4, which is, again, the period ends right there, right? So that would be 4 pi over 4, which is just 4. This would be 5 pi over 4. And then this one would be 6 pi over 4, which would be 3/2. 3 pi halves. OK, so now basically we need to go ahead and take this graph and transform it down here, where again our starting point is at negative pi halves. Let's see. So now you can see my amplitude is at 4. So I'm still going to use my y-intercept, or my y-axis, to determine the amplitude, or to show the amplitude. So instead of the graph going up to 1 and down to -1, it's now going to go up to 2, up to 4 and down to 4. OK, so unfortunately, I'm not graphing them on the same scale. So you can see that the amplitude is actually vertically stretching the graph. But you'll be able to at least get the idea. So again, since these are both cosines, they're going to do the same thing. Where it starts, it's going to start at the max. Then the next point is going to be the intercept. The next point, critical point, will be the minimum, intercept, back up to max. OK? Then we can just continue the pattern. Intercept, minimum, intercept, maximum. OK, boom, done. All right, so now let's go and get to the next one. For the next example, we're going to be doing the same thing here, except now we need to identify the amplitude, period, x scale, and where our start is going to be. And then we'll just go ahead and get into the graph. Now, the first thing I notice here is when doing the amplitude is, let's use a different color. First thing I notice when using the amplitude is I notice that the amplitude is negative. Well, that's not a problem. The amplitude is actually, or the A is negative. The amplitude is never going to be negative because it's the absolute value. However, what that is going to tell me is now my graph is going to have to be reflected over the x-axis. So I'm going to do that absolutely last. OK? So I'm just going to graph this just like this is a positive one, but then I'll reflect at the end. But you want to make sure sometimes, like to write, reflect, especially like on a test, so you kind of remember to do that. Or don't use it in this way and just do it from the beginning. Amplitude, so the next thing is now we need to determine the period, which is going to be 2 pi over b, which in this case, you can see my x is being multiplied by 2 pi. So that's going to be period is 2 pi divided by 2 pi, which is just going to be 1. My x scale is going to be my period divided by 4, so that's going to be 1/4. And my start here is going to be this crazy equation, 2 pi x minus 8 pi equals 0. OK, because again, the initial period starts at 0. So we're going to set what's inside the function set equals 0 and then solve for x. So the first thing I'll do is I'll add 8 pi. 8 pi. So therefore, I have 2 pi x equals 8 pi divided by 2 pi divided by 2 pi. X equals 4. So that means I'm going to now start at 4. Where you're like, starting at 4? Yeah, we're not starting at the y-intercept anymore. So, or the y-axis. So here's where I'm going to be the start. And in this case, I'm going to do a start. I'm going to do points to the left and points to the right. So I know if here's going to be my start, which is at 4, I know I'm going to do 4 critical points to the right and 4 critical points to the left. Whereas this case, I just did 8 critical points to the right, right? So you could do either way. So it'll be 4. So we know this one is 1, 2, 3, 4. Well, sometimes it's easy. Now, again, guys, remember pi represents like 3.14 on and on, right? 2 pi would be 6.28 on and on and on. So you can see that, here, if that's 3.14, then you could see that like that would be 3, right? And you could have 4 there as well. So the numbers and the pi scale is, you can have the scale on the same axis. It's just different. It's just different ways that we, they're just obviously irrational and rational numbers. Then we have 3, 2, 1, 0. Now, let's scale that a little bit better. I think that looks a little bit better. OK, so here's going to be my start. And again, you can see at 0 here, now here's going to be my y-axis. And the amplitude, though, is just going to be 1 and -1. So I'm just going to go up to 1 and down to -1. OK. So now what we're basically going to be doing is, again, graphing. And as I mentioned, when I go ahead and do this, we're going to start here, right? So whenever we start, at our starting point, we're always starting from the top. And then I go down, minimum, intercept, up. So this one, if it starts up, it's going to go intercept, minimum, intercept, up. So without the reflection, the graph would look like this. Right? But remember, we're reflecting this over. That means all the points that are above the y or x-axis are now going to be below the x-axis. All the points that are below the x-axis are now going to go above. And all the ones that are still on the x-axis are just going to remain the same. So I have a lot of students that will do this, and they'll forget to reflect at the last moment. So it's kind of important to kind of remember that. And that's why I always like to, whenever I see a reflection, always know that I'm going to be using some negative points here as well. So there you go, ladies and gentlemen. That is how you graph the cosine function with a phase shift. Thanks. Hello. That was long.